Hey guys, welcome back. I'm Ostrus. Today we are going to take a look at WAN 2.2 image to video 14 billion parameter model. I just added support for this yesterday in AI Toolkit. Let's take a look at WAN 2.2 I2V 14B. That's a mouthful. I'm going to explain what's new, how it's different than version 2.1, how it's different than 2.2 version 5B, and so on. So let's get started. So the 14B, or A14B as they call it, is a little different than the 5B version. In fact, it's a lot different. I did my first video on the 5B version. For one thing, the 5B version only comes with one variant. It has text, image to video. Secondly, the 5B version goes down 16x latent space. So as opposed to WAN 2.1, it goes down 8x. So the 5B version's super efficient, goes way lower in the latent space, twice as compressed. This one also does text and image to video, and it also only has a single transformer. If we pop over to the diffusers version, you can see there's only one transformer here. I view it as this is actually like a 2.2 version, maybe even a 3.0 version. But the 14 billion parameter is quite a bit different. It actually is very similar to the 2.2 14 billion parameter architecture. The only difference being that it actually has a transformer, or has two transformers. So first transformer does really high noise early in the denoising process, and the second transformer does when it's low noise. So it's not split 50-50 on the time steps, but the way that you shift the time steps, it's 0.875, I believe. It's actually like 87.5% of the time step, but the way you shift it, it's around 50-50 when you're actually inferencing. So that's how we have to train it. So this adds some training complexities having the dual transformer versus the 5 billion parameter. You don't have that. It's 14 billion parameter, but that's per transformer. So each one of these has to be trained separately. So you end up with 28 billion parameters, and it's a video model, so you're doing a lot of frames through it. All of this creates a lot of complications. This is why it took a little bit to implement. Hopefully we can train this on as little VRM as possible. I'm still trying to figure out where exactly those lines are, because training on images is different than training on short videos versus long videos versus big videos that are short versus, I mean, there's just 100 different ways that you can feed data into this thing that it makes it real hard to say, yes, you can train on 24 gigs, because you can with the right quantization, training on the right images, training on the right frame count, I mean, there's just a lot at play there. I'm going to go to runpod because I need a beefier GPU than I have at home. Unfortunately, this is the one I want because I love this GPU. And it's currently unavailable. So let's just wait here a second. I'm going to refresh a few times. Maybe we can get our hands on one. All right, it's available. Let's see. I've been waiting here for a while. I'm going to go to Edit Template, Environmental Variables, change the password to AI Toolkit password, my secret password, set override.
And it's gone.
It's back. Let's see if we can get it this time. Edit Template. Environment variable, come on. Yeah, toolkit password, set overrides. All right, we got one. Finally. That took about an hour. And if you don't have runpod, check the description. I'll have an affiliate link. That just gets me a little extra compute so I can make these videos and train models and things like that. The pod is up. I guess they just changed their UI, so I'm not really sure. Think we're good here. HTTP service. Okay, yeah. They changed everything, so it took me a little bit. Okay, so this is our password that we put in the environment variables. First things first, let's make a data set. Pop over the data sets, click new data set. And what are we going to train today? We're going to train some camera movements. So I'm going to do orbital. And I have tested the model, and it does not know camera movements, at least orbital camera movements. I have tried to generate some synthetic data with this. We'll click Add Images. Generating the synthetic data was really difficult. I have two synthetic ones just because I wanted to have people in it. I'll show you why. I'll drop those in. I wanted to have people in it, but when I tried to make the synthetic data set, I had to do a light denoising, and no matter what I prompted, it was just almost impossible. I mean, I had to denoise like 20% every single time. And so I just did that over and over and over to slowly change the images. But you'll see they're not that much different. Sometimes on cloud service, this doesn't work great. So especially doing videos, because these are so big. So I'm just going to do a few at a time here and just drop them in like 4 at a time. All right, we have them all uploaded. Let's take a look at what we're doing today and talk about how to do dataset preparation. What I'm going to be training, it's called an orbital shot or a 360 tracking shot or a 180 tracking shot. Basically, the idea is you have something in the middle and it goes around and spins. Okay, I can't adjust this. That's a problem. Anyway, it goes around and spins like that. So some of these have 360. This one's 360. Some of these are going to be 180. So they're only going to spin around halfway around. And some of them, yeah, they're all a little different. Some spin to the left, some spin to the right, etc. So for instance, these are all 360. This one I believe is 180. So I got all of these videos off Pexels. I'll post a link in the description to that. And you can get royalty-free videos and images on there. One of the problems, though, as you can tell, a lot of this is all like drone footage. Some of it kind of works, but generally it's all very drone footagey. If the data set only shows a certain type of thing, so it only shows, you know, an object out in the world, like a big object, then doing something smaller is not going to work that good because the model will learn not to do it, like with my crush video. So I did find 2 videos of like people, and they're just like, you know, the thing is they don't have any kind of background or anything. So the model won't know if they're spinning in the world or the person's spinning in the world staying still. So I have a woman and I have a man. They're both doing this. So I actually took her, did an image or video to video on and using the WAN 2.2 14B model with a light denoising, and it took me a few tries, and I actually had to superimpose some of these other spinning videos on it to make the background spin because it was just spinning the person. But I ended up making these. All right, so we have her and we have him. Okay, now you may notice they're wearing kind of similar clothing. They're kind of in similar positions. He has a long ponytail. This is because this image, or this video, was used to make this video. Just doing light denoising is like 20 iterations of videos here to get it to this point. I tried to make his shirt green, whatever. This is just where we are now. So let's caption these up. Now, one cool thing about this, I'm not going to caption if it's going left or right, but I do want to caption if it's an orbit 180 or an orbit 360. That way we can define that in our testing data. So we can say, you know, orbit 180 to just spin around to the other side, or we can do orbit 360 to spin all the way around. Got them all labeled. So there's orbit 360s, there's orbit 180s. It's around 50-50. There's more 360s, but that's, you know, it should be okay. Should be able to learn either one. Either way, we're teaching it to orbit, so that'll be fine. One thing I do want to note, so I did kind of crop and like position some of these, but you can notice the times on these. This one's 24 second, this one's 32, this is 27, 32, etc. I should have probably shrank these down or sped them up to make it where they're 5 seconds. For WAN 2.2 14B, we're shooting for a 5-second window there. So, but it doesn't matter because the data loader will automatically evenly space out these frames. So for the 1 minute, you're going to space the frames evenly along the 1 minute. For the 12 second, it's going to evenly space them along the 12 seconds, 28, etc. So it doesn't really matter other than the video files are longer. It could take the data loader longer if it's a bigger file, but it's fine either way. It's going to automatically handle it. So the only thing you want to do is you want to make sure that you crop the videos mainly for the start and end of the spin, like you can see here. So it starts the spin, comes around, and then there's no extra stuff. Just get straight to the spin and it's done. So that's what we're doing today. We're training an orbital shot or 360 tracking shot, 180 tracking shot, whatever you want to call it. This is what we're doing. Now I know the model can't do this because when I was creating these, it was a giant pain to get them here. So we're going to teach the model something new. That's exciting. We're going to go ahead and come over to a new job. We're going to name this one Juan 122 14B I2V. Just so many acronyms you got to put in here. Orbit. Awesome. Gee, we aren't going to use a trigger word since we use the captions. You could do a trigger word if you want. We're going to go down here. Getting a lot of models in here now. Juan I2V. That's what we're training today. And you'll notice when I selected that, this multi-stage thing pops up here. So this is a thing about Juan 2.2 14B. It has a high noise and low noise. You can click on here to read more about how those work. And then it switches every. So I'm going to use, we're on a beefy GPU. I mean, we have 96 gigabytes of VRAM, something like that. So I can train these at the same time. So I'm going to switch every one. I'm only going to quantize to float 8, etc. You may want to move this down depending on what you're doing. I wouldn't go below 6 or 5 bit. I'm working on an accuracy recovery adapter for this. I trained one actually, just the quality wasn't there, but that may be here when you get there if you're doing 24 gigs of VRAM or 32. If you see that here, that's a great option too. I don't need any of that because we're just going to do it high. Okay, I'm not going to use low VRAM because I don't need to. One thing is if you have the low VRAM option on and you do switch every, so what's going to happen is right now it's switching every one. So it's going to train the high noise model for one step, and then it's going to train the low noise model for one step because we're switching every one. If we do it for 10, it'll do 10 steps on high noise, 10 steps on low noise. If you have low VRAM on, it's going to, when it's training the high noise model, it's going to unload the low noise model. When it's training the low noise model, it'll unload the high noise model. So switching every one step, this takes time. Transferring the whole model on and off the GPU, you really don't want to do it every step, and there's no point to really do it every step because 10 training steps on high noise is 10 training steps on high noise, you know, so do it every 10 or so. That'll be fine. So I would do 10 if you're doing low VRAM. You're going to need this for most consumer grade GPUs. Since I'm using an RTX 6000 Pro, I don't. I'm going to leave it at 1. So we're going to do both models at the same time. You can train just one or the other. So if you just want to train low noise, so let's say you're doing a character or something, you're training images in, you may want the high noise to still build out the whole composition of the, you know, everything happening in the scene. You may just want to train low noise. That'd probably be great. It may get hair colors wrong and things like that, but that would probably work great. And there's going to be other times where you just want to work on composition. In fact, right now with what we're doing, we could probably get by just training the high noise. But I'm going to do both just so we can see how it works. Since we're doing 14 billion on both, I could leave this at 32. I don't think I need that much. I'm going to do it 16. That should get us by. You could do 32. I wouldn't go above 64 here. We can leave all of this the same. 3,000 steps is probably fine. The time step type. Since the model is switching back and forth between high noise and low noise, this actually happens. So if you don't know, time steps are 1,000 to 0. And 1,000's the noisiest time step, and then there's 0 with basically no noise at the end. The high noise is going to train from 1,000 to 875. So it's just that really high noise range. But the way that the shift and all that works, this happens about halfway through the diffusion process. So it's not perfectly 50-50. It doesn't train it down to 500 time step, let's say. but it does do it at 875, and then the other ones from 875 to 0 is here on the low noise. But the way that it shifts, when you do the shift, it's about 50% of the way through the denoising process. So because of that, it's not going to be true linear. It's still going to be 50% on the low noise, 50% on the high noise. So we can leave it at linear. These other time steps will still function. I just wouldn't recommend using them right now. I mean, linear is just kind of the way that this model works. This is going to work fine. You could do weighted if you want, but I'm going to go with linear. And that's the default. We don't need to do any of this. You probably want to cache the text embeddings. If you are on low VRAM, just unload that text encoder. In fact, I'll go ahead and cache it. That's fine. Scroll down to the data set. Okay, we have orbital, LoRa 1. Everything here's fine. We don't need the train at 1024. That's way too big, especially for an image to video model. If you're on low VRAM, you may want to stick to 512 or less. We do want to do number of frames. Now, if you saw my WAN 2.2 5 billion parameter version, the 5 billion parameter is not the same model as the 2.2 14 billion. It is in a lower latent space. You actually generate like 121 frames here. You can't do that with the 14B. It wasn't trained on that. So instead of 121, we're going to stick with 81. And I believe this kind of goes through that. Yeah, 81, you can see it there. So 14B, 81, this is about as far as you want to go. You could do 41 here. You could do, actually just for speed, let's do this at 41 frames. So this will be a quick little rotation. Since we're just doing a video, and this will literally double or cut our training time in half. Another thing you might want to do, you can always start out with less frames. So you can start out with like 9. And then, so remember, you have to have multiples of 4 plus 1. So you can do 4 plus 4 is 8, plus 1, 9. You can do, 16 plus 1, 17, etc. 40 plus 1, 1. And all that's explained up in here. You could, if you want to stop and start and stop it. One thing you could do is actually, start out with 9, train a few, stop it, go up to, like 17, train a few, stop it. I'm just going to start out with 41. 41. This is kind of a mid ground. The model was trained up to 81. But this will allow us in our samples, we're going to do 41. So speaking of samples, let's go down to samples. I'm only going to do 4. Normally, I only recommend doing 1 or 2 for videos because videos are slow. But since we are doing a tutorial and we're going to be doing a whole video and it needs to be entertaining, let's do more. All of these we'll do 2. Actually, we'll do the first one, orbit 180. We'll do the first 2 180 and the second 2 360. Perfect. Now for images. Remember, our data set has a lot of like drone footage orbiting castles or buildings, things like that. So to start out, the very first one, we're going to make it easy on the model because we want to see if it can transition this knowledge to other things. So the very first one we're going to do is going to be this. So this is kind of like footage it's seen before. The drone kind of circles around it. That one, it should be able to pick up pretty easy. For the second one, we're going to do this one. So this is kind of the same thing, but we're kind of transitioning into people. So this is a woman sitting on a rock, like on a cliff. And so it is still kind of outside, like could actually be drone footage. So this one, it should be able to pick up as well. We're getting progressively harder in our samples though. For the next one, now we don't have anything in our data set like this. I love this picture. So it's this girl, she's holding lights. So she is outside. So maybe this can circle around her. I don't know. This one may fail because we don't have stuff like this in our data set. I don't know what's going to happen with these light orbs. Real excited to see how this one works out. For our last one, We're going to be doing a close-up of a man's face. We don't have any close-ups like this that are close-up. Look at him. He's got his turtleneck on and all that. Like he's about to go start an Apple computer company. All right, let's recap. We have our training name, WAN 2214B image to video orbit. We are going to train on the WAN 2.2, I2V 14B. We're going to use everything the default. I'm not going to use low VRAM. I recommend you do this on any consumer grade GPU. I'm just going to quantize float 8. I'm going to do high noise and low noise. I'm going to switch every one. LoRA rank is 16. Leave everything else linear. We're going to cache the text embeddings. Orbital, we're doing 41 frames, 16 frames per second, 41 frames on the sample, and we're doing 4 images, and we're going to orbit 180, 180, 360, 360. That's enough talking. Let's create the job. Now we're just going to hit the little play button and cross our fingers. All right, we have our first samples in. First, let's take a look at the training, though. So right now we're on step 7. Remember, it's switching every other one on each transformer. So we're getting the high noise and the low noise at the same time. We can take a look over here. We are at 67.2 gigabytes of VRAM. Now, I'm not unloading one of the transformers. You can unload one of the transformers using the low VRAM option. We do have the text encoder unloaded, though, since we cached the text embeddings. We also are only using float 8 quantization, so you can get this number down quite a bit, just unloading one of the text encoders, do float 8 quantization, etc. But let's check out some samples. Nothing's rotating. Let's take a look. One thing I did notice when these were generating, they took a while to generate. I'm generating at 1024 by 1024, so these are big. But I thought about changing it, but I'm going to leave it. I'd actually recommend you guys do it at 768 or lower because these samples take a long time. And it's not that important for this type of samples. But for the video, we're going to do high quality here. You can tell it's not rotating. It's kind of zooming in a little bit. The quality is amazing, though. This lady's just kind of fiddling around on the rock. Oh, man, I just love this picture, and I love that there's movement already. I'm really curious if this can go around. We'll see. Steve Jobs looking guy here, tech bro. These are our first samples. This is without any training, just so we can get a baseline of what the model knows. It does not know orbit 180. I've tested already. It also doesn't know take this image, spin around 360. I've typed huge prompts. Let's see what happens on our next samples. The first training samples are in. We're at 250 steps. Let's take a look and cross our fingers while I click samples. Oh yeah, nice. Okay, so we're getting movement. Let's take a look at these. You can tell the first one, nothing was happening, kind of zooming in a little bit. And now we have full-blown spinning. So the first two, remember, are only going to do 180, or at least that's the goal. So this one and then this one. Okay, it's a little choppy, but you know, some of our videos are pretty choppy, if I'm being honest. But yeah, so this one should do a 180 to the other side of her. But from this, where it wasn't rotating at all, to this, much better. All right. We're getting some spinning. There's definitely a lot more movement happening. See, it was just kind of sitting there, twiddling. Much better. These are supposed to be 360, which they're obviously not yet. And then we have this guy, and he is now jittering. So we've made him jitter. That's the good news. I'm going to run this out to 3,000 steps unless something goes wrong. I'll see you guys here in a bit. It is day 2 for me. For you, it's a few seconds later. Some of the reason why it took so long is because I'm sampling at 1024 by 1024, and I'm doing 4 samples. So that slows it down quite a bit because it takes a while to generate those. But other than that, it is a video model, and it does take time. So we are done. I'm excited to check this out. Let's go to samples. Let's see if we got some spinning in. Spinning in. All right. Great. Let's take a look one at a time. I mean, it's working. Working great. Okay, there are some artifacts on the spin. This one's supposed to go 180. It looks like it is doing 180. That's good. Okay, let's look at the next one. It says the girl sitting on the rock. Yep. This one's supposed to go 180 as well, but it looks like it's doing 360. It may not be able to learn the difference between the two, but that's fine. Okay, this one should be a 360. Oh man, I love how it's handling those lights. Okay, perfect. And we have hipster Steve Jobs. All right, so this one's working. Complete 360, that's great. So the model comes out with a high noise and low noise. Okay, remember we trained both. It takes longer to do that, but one thing I want to check out is when we try this out in Comfy, we can see if doing just the high noise and just the low noise LoRa's, so we can see if we could get by with training just high noise, if that'd work better, if the low noise will just kind of do whatever the high noise told it to do. I don't know. We're going to see. Let's get this downloaded and put this in the Comfy. If you don't know, we can just click right here on the high noise, low noise. So let's go ahead and download these. All right, I save them there into my Comfy folder. And I'll do both. So you can see here we have the high noise. Let me kind of expand this out. So we have the high noise LoRa. This is only connected to the first part of the sampler. So the way that this works is Comfy's going to do with a shift of 8. It will do 10 steps. So it starts at step 0, ends at step 10. And it's going to do a total of 20 steps. So it does that on the high noise. And then on this side, we have the low noise LoRa. Be sure you don't mix these up. They probably won't work interchangeably, where you probably can't mix the high noise LoRa with the low noise and vice versa. Although you might get a cool effect. I don't know. Try it out. Let me know how that goes. Other than that, let's see. We're just doing basic shift of 8. I'll probably post this workflow so people can use it, but it's the basic. It's the standard Comfy example workflow. I've just kind of cleaned it up, rearranged some things, added the LoRa loaders for the model only. That's it. So we're going to give it a run. I'm going to do Orbit 360. I already have an image loaded here. This is Van Gogh self-portrait, and I cannot wait to see what it can do with the painting. So we're going to give that a shot first. Let's give it a run. Okay, it is doing some kind of painting tornado thing. I'm going to try it with, so right now we're not giving it any context to what this is. So orbit around a man. Let's try that. Maybe if we give it context that this is a man, it'll orbit around him. So we're going to give that one a run. All right, our additional prompt does seem to help. It looks like the painting effect kind of goes away. I mean, it looks awesome, but it instantly blips away from the painting. So let's do around a man painting style. Let's try that. Maybe it'll keep the style of the painting. All right, this seems to be working quite a bit better. We're not seeing all the stuff on the other side, but I mean, it is spinning. It's spinning consistently. Let's try another image. I want to try the distracted boyfriend meme. So let's change this. Orbit 360 around a group of people. Just leave it at that. All right, lovely. It's spinning around the guy. That's fine. It's kind of interesting. It does lose some quality here. All right, so what I want to try on this one, we're going to try this. We already have a fixed seed, don't we? Yeah, we're fixed. We'll leave that fixed. I want to try it. Let's see what it looks like with only the high noise model, because that should do all the composition. I'm really curious if the scene will look better with just the high noise model, or we can also try just the low noise model. So for now, I'm going to disable the low noise model. Let's run that, and let's see what it looks like with just the high noise model. Luckily, it's already cached, the first part, so it just has to do the second. Or it doesn't look like it's much different. Maybe a little blurrier on some of these transitional effects. Let's try it the other way now. So we're going to do it just the low noise. All right, so doing just low noise does not work. And this makes complete sense. We're training composition here. And this is one of the reasons why doing a composition, you want to focus more on those early time steps in general training. Here, he's just kind of whistling at her, but it's not doing the spin because most of the image is denoised by the time it gets here. So it can't completely change that composition. Let's activate this. That was a fun little experiment. I'm going to do this one on my dad because I love this picture. Around a man. Oh, it works great. Get a nice 360 of my dad when he's in high school in the 70s. The background's not spinning, but you know, it's kind of a solid background anyway. I think that's fine. I love this picture. This picture is used on the banner on X. This is just Doc Brown from Back to the Future, except it has a face swap of my face in it. All right, it is not actually orbiting, but it's spinning all the way around. So, I mean, it's a win-ish, maybe. We'll see if it can actually like spin the logo. I'll put Orbit 360 around a white logo. It's not quite what I'm going for. There, let's try that. That way I could actually use it in my video if it doesn't say Koabayabi. It's not orbiting, but it's kind of neat in a way. It'd be a good little loading icon. All right, so we're going to use the famous Neil Armstrong photo on the moon. Orbit 180 around an astronaut on the moon. The Earth is exploding on the other side. Let's see if it can take that additional context. It's spinning great. You're actually seeing, it's kind of interesting because you're seeing what's in the reflection on his mask. Because you have the lunar lander there. Hold on. Yeah, you have the lander on his mask. And because of that, the lander is on the surface. That is crazy that it can do that. I mean, I didn't prompt for a lander. It's supposed to be exploding Earth on the other side. Okay, I know I promised this was the last one, but this makes me want to run a better, longer version. So I'm going to set the megapixels to 1. I'm going to set this to 81. Remember, we only trained it at 41. So I'm going to do it at 81. It's almost twice the length. But this is the length that the actual model was trained on. So it should be able to handle it. And hopefully everything that we've trained it will transition to the longer one. I'm gonna remove the Earth is exploding on the other side because I'm really digging that it's pulling out that concept from his mask. It's mind-blowing, absolutely mind-blowing. Amazing. It still has the lunar lander that it's picking up from the mask. It works for the longer video now because we did it twice the length of what we trained it for. We're also doing it at a much higher resolution than we trained it for. I guess I can go ahead and zoom in. It works pretty damn well. I just uploaded the LoRA onto Hugging Face and I tagged it with the model, and I came over here and I noticed there's only one adapter. And if you go to that, it's the one I just uploaded. So I guess first on Hugging Face. That's always fun. That's it for me. And if you enjoyed this video, or you enjoy AI Toolkit, or you enjoy my work in general, please be sure to like and subscribe to this channel. Like the video, subscribe to the channel. That really helps me out on YouTube. But if you want to support me further, you can go check out ostris.com/support. I'll put a link in the description. Here you can see how you can help support me financially. I do open source and I work on AI Toolkit 100% of the time. This is how I make my living. So every little bit helps. You can scroll down here and you can see some of my current supporters and sponsors. All of these people and these organizations are the people who help make videos like this possible. So you can join the elites and you can see your face on here next time. That's it. I'm out. See you next time.